In the early hours of May 18, 1980, following a 5.1 magnitude earthquake in Washington, USA, Mount St. Helens erupted, initiating a 9-hour-long eruption, a debris avalanche, and a landslide. A series of small earthquakes began on March 16, 1980. The initial explosion caused a wide crater to form at the summit of the volcano's ice cap and ash to cover the volcano. Afterward, the earthquakes continued at a rate of 1 per hour in March and 1 per day in April. Previous to the eruption on May 18th, there was a total of 2,800 earthquakes. The magnitude 5 earthquake on the morning of May 18th caused a release of pressure in the cryptodome of Mount St. Helens. The volcano's summit slid downwards, and the debris avalanche that occurred was the largest recorded in Earth's history.
Mount St. Helens, located near the city of Seattle, resides on the boundary between the Juan de Fuca oceanic plate and the North American continental plate. As the two collide to form a subduction zone, Juan de Fuca is forced downwards and the oceanic crust melts and releases less dense materials such as water and gases. As they rise, rocks are absorbed and magma chambers are formed. These chambers erupt when disturbed, which is what happens due to the earthquakes around Mount St. Helens previous to its eruption. The explosion proved that volcanic eruptions could be accurately predicted.
Volcanologist David A. Johnston was studying the events at Mount St. Helens up until the moment of the cataclysmic May 18th event. He was 6 miles from the volcano, manning an observation post before being killed by the lateral blast of the eruption. Many devastating events occurred as a result of the disastrous explosion. Of the 57 lives lost, many were of asphyxiation from the pyroclastic ash. $1.1 billion of damage was caused by Mount St. Helens, including the destruction of 158 miles of highway, 200 homes, and 15 miles of railroad tracks. The eruption impacted an area of 230 square miles. In total, 900,000 tons of ash were removed from highways and roads post-eruption.
The excruciating heat and ash from the eruption wiped out over 230 square miles of forest surrounding Mount St. Helens. After the blast, it seemed like all hope was lost for the multitude of species that had resided in the area. But much to scientists' surprise, some species had managed to survive. The springtime eruption meant that plants were at their least vulnerable point. The northern-facing slopes were protected from the blast and covered with snow. Erosion cut through new lava deposits and distributed valuable minerals that enriched the soil and allowed plant life to recover. Carbon, sulfur, and iron were leaked into surrounding lakes and actually boosted the lake's diversity and productivity levels within the first year after the eruption. Pictured here are 2 beakers of water from Spirit Lake. The one on the left is from shortly after the eruption, and the one on the right is 1 year later. You can observe how the minerals and microbial activity improved the overall health of the lake. Flash forward to today, and ecosystems around Mount St. Helens are thriving and act as an observatory for scientists to study how ecosystems can successfully recover from natural disasters.
The catastrophic eruption of Mount St. Helens is still remembered today as one of the most monumental eruptions in volcanic history, proving that volcanic eruptions could be accurately predicted and resulting in scientists and professionals looking further into past activity in order to predict other eruptions. Shortly after the events of Mount St. Helens, the Volcano Disaster Assistance Program was started to help respond to volcanic disasters around the world.